Good morning, everybody. Welcome to Tippett's Physics Regents Review. What is crappening? Today, we're going to look at projectile motion conceptually. So let's look at the easiest part. When you throw something in a horizontal motion, we neglect air resistance. So as soon as you let go of the ball or the object, it's going to travel at a constant velocity. So it travels at constant v. Again, that's in the horizontal or the x direction. Because it travels at a constant velocity, the only formula we could use to analyze it is velocity is distance over time. And that's velocity in the x direction. Now, if by chance this were at an angle, in order to find the horizontal component, Vx is v cosine theta. And that's horizontal motion for a projectile. Now, in the vertical motion, things are either falling down or being thrown up. So we know in the vertical motion that they accelerate at the rate of gravity. So acceleration is g, which is negative 9.81 meters per second squared. So even when you're throwing the ball up in the air, as it's going up, Earth is pulling it down, so Earth is slowing it down, which means it's going to go up, slow down, stop, and then come back down. So we know at the top, the velocity is 0 meters per second. Because gravity, or because Earth is constantly pulling down on it, we know that the force acting on the object is a force of gravity. So Fg always acts on objects. We also know that when you throw something up, the velocity you throw it up with, if you catch it at the same exact height, is the velocity that it comes down with. So Viy is equal to negative, let me get rid of that sign to the left of Vi. Viy is equal to negative Vfy. So if you throw something straight up with a velocity of 10 meters per second, when you catch it, it's going to go at 10 meters per second as well. Okay, let's see, what else? Now let's look at it combined. So let's say you're standing on a building and you throw something horizontally. And let's look at two objects. Let's say you throw a 10 kilogram ball 5 meters per second. So we have a 10 kilogram going at 5 meters per second. And we'll say a 3 kilogram going at 10 meters per second. And let's say 20 meters per second. 20 meters per second. Because gravity is pulling on both of these objects exactly the same, they fall at the exact same rate. So they're going to hit the ground at the exact same time. So number one, they hit ground at the same time. Number two, because you're throwing the 3 kilogram ball faster, even though they hit the ground at the same time, you're throwing it faster, so it's going to go farther. So the faster you throw something, the farther in the x direction it goes. A couple more things. One, the sweet spot to get the maximum distance, so to get the maximum x distance, max x distance, when hit at an angle is 45 degrees. So that's the sweet spot. Now to get the maximum height, that's in the vertical direction. Maximum height. Well, to get it go as high as possible, you want to throw it straight up, so that angle is at 90 degrees. So, a quick summary. In the x direction, travels at a constant velocity, so it does not accelerate in the x direction, no acceleration. In the vertical direction, it's always accelerating at negative 9.81 meters per second squared. So it goes up, slows down, stops, turns around. And then lastly, all objects fall at the same rate. Therefore, they hit the ground at the same time when thrown at the same height. And that's it for Projectile Conceptual. Please like or subscribe if you found it helpful, and good luck. Thanks.